Welcome to the next topic, Lorentz force from your third lesson, 12th standard physics. What is meant by Lorentz force or statement of Lorentz force? When an electric charge Q is kept at rest in a magnetic field, no force acts on it. At the same time, if the charge moves in the magnetic field, it experiences a force. This force is different from Coulomb force studied in Unit 1 lesson. This force is known as magnetic force. It is given by the equation F vector is equal to Q into V vector cross B vector. In general, if the charge is moving in both the electric and magnetic field, the total force experienced by the charge is given by F vector is equal to Q E vector into V vector cross B vector. It is known as Lorentz force. That means, simply says, what is meant by Lorentz force? If the charge is moving in both electric and magnetic fields, the charge experiences the total amount of force. It's nothing but F vector is equal to Q into E vector into V vector cross B vector. Is nothing but Lorentz force. Simply says moving charges experience the electric and magnetic field force. Is nothing but Lorentz force. Once again repeat. When an electric charge Q is kept at rest means in a magnetic field, no force acts on it. At the same time, if the charge moves in a magnetic field, it experiences a force. That force, this force is known as magnetic force because charge experiences a magnetic force. That is why we called as a magnetic force. So the equation is F vector is equal to Q into V vector cross B vector. If suppose the same charge is moving in a both electric and magnetic fields, the total force experienced by the charge is given by F vector is equal to Q into E vector into V vector cross B vector. What is meant by Q? Charge. What is meant by E? Electric field. What is meant by B? Magnetic field. What is meant by V? V is nothing but velocity of the charge. It is known as Lorentz force. The next topic is force on a moving charge in a magnetic field. When a charge, electric charge Q is moving with velocity V vector in the magnetic field B vector, it experiences a force called magnetic force Fm vector. After careful experiments, Lorentz deduced the force experienced by a moving charge in the magnetic field Fm vector. Fm vector is equal to Q into V vector cross B vector. In magnitude, Fm is equal to QVB sin theta. So important points. There are 8 important points in the magnetic Lorentz force. First point is magnetic field force Fm vector is directly proportional to the magnetic field. Fm vector is directly proportional to the magnetic field. Here Fm vector is directly proportional to the magnetic field. Fm vector, second point is Fm vector is directly proportional to the velocity. So that means magnetic field is increases means force also increases. Velocity of the charge is increases means force also increases. The third point is Fm vector is directly proportional to sine of the angle between velocity and the magnetic field. So directly proportional to the sine of the angle between the velocity and the magnetic field. Then fourth one is Fm vector is directly proportional to the magnitude of the charge. That means magnitude of the charge always increases means force also increases. Then fifth point is direction of the Fm vector force is always perpendicular to here, perpendicular to magnetic field and the velocity of the charge, velocity and magnetic field of the charge. So the direction of the Fm vector is always perpendicular to V vector and B vector, as Fm vector is the cross product of V vector and B vector. Then the seventh point is the direction of Fm vector on negative charge is opposite to the direction of Fm vectors. If suppose negative charge passing through the electric and magnetic field, what happened? Direction of Fm vector on negative charge is opposite to the direction of Fm vector on positive charge, provided other factors are identical. The last point is if the velocity v vector of the charge q is along magnetic field, q is along magnetic field b vector, then Fm force is 0 because magnetic field and the electric field always perpendicular to each other. Here q moving along with the magnetic field means force is equal to 0 because charge is does not affected by the magnetic field, because both the field and charges are moving in a same direction, that means parallel. So there is no force acting on the charge q, so that is why force is 0. Then definition of Tesla. The strength of the magnetic field is 1 Tesla. Note it down, very important point. Strength of the magnetic field is 1 Tesla. If unit charge moving, 1 coulomb charge moving in it with unit velocity experiences unit force, 1 Tesla is equal to 1 Newton second divided by coulomb meter. 1 Newton is otherwise written as 1 Newton divided by ampere meter is equal to, what is the unit of 1 Tesla? 1 Newton per ampere per meter. So 1 Tesla also written as 1 Newton per ampere per meter. Once again repeat the definition of Tesla. The strength of the magnetic field is 1 Tesla. Strength of the magnetic field is 1 Tesla. If unit charge moving in it with unit velocity experiences unit force, is nothing but definition of Tesla. Once again repeat the important point of magnetic Lorentz force. Force is directly proportional to the magnetic field. Then force is directly proportional to the velocity v vector. Then force is directly proportional to the sine of the angle between the velocity and magnetic field. Force is directly proportional to the magnitude of the charge q. Then direction of the force is always perpendicular to the velocity of the charge and magnetic field, as force is the cross product of v vector and b vector. Then the direction of force on negative charges, if suppose negative charge moving in the electric and magnetic field, force on negative charge is opposite to the direction of Fm vector on positive charge, provided other factors are identical. The last point is if velocity v vector of the charge q is along magnetic field b vector, then Fm vector is 0. Once again repeat the last point. If velocity v vector of the charge q is along magnetic field b vector, then Fm vector is, that means force is 0, because charge moving along with the magnetic field means the charges does not affected by the magnetic field, because electric and magnetic field always perpendicular to each other. If suppose parallel to each other means there is no force acting between the magnetic and the electric field. So that is why the charge, if suppose moving along the direction of magnetic field means there is no force acting on the charge q. That is why the force is 0. Thank you.